students, welcome to the on-site classes at the rate of PC Method. I am AMK. Today, I am going to solve a problem of physics of class 12 of chapter ray optics and optical instrument. The problem is a tank is filled with water to a height of 12.5 centimeter. The apparent depth of a needle laying at the bottom of the tank is measured by a microscope to be 9.4 centimeter. What is the refractive index of water? I need to calculate the refractive index of water when an object is any object or here considering a needle is laid down in the depth of water, that is 12.5 centimeter. If the water is replaced by a liquid of refractive index 1.6 centimeter to the same height, suppose water is replaced, then another liquid of refractive index 1.63 to the same height is filled. By what distance would the microscope have to be moved focus to the needle area? It means microscope should be shifted to a distance to focus the needle again. Okay. Now I will discuss it with an example with a diagram. Then suppose here is a tank. It is a tank. This is the depth of the tank, 12.5 centimeter. Depth of the tank is considered as a real depth. It is the real depth. Okay. Now here is water. And here is the position of the needle. Okay. And it is the medium air. Water is denser medium would compare to the air. Okay. Now, when I am considering a ray diverges, it means this ray is reflected from denser medium into the rarer medium. After refraction from denser medium to the rarer medium, reflected ray gone away from the normal, and producing this ray, there will be an image of this needle here. And see, this is the apparent depth. And this is normal shape. Right? Now I am going to solve this problem using this data or using this figure. Now case 1. This problem have two cases. Therefore, I will use first case and second case to solve it. Refractive index of water is equal to real depth by apparent depth. Refractive index of water is calculated. I have to calculate, no? Then real depth is what? 12.5. And the apparent depth is 9.4. It is 9.4. And now 125 by 94 by calculation. By dividing 125 by 94, I will have 1.33, which is the refractive index of water. First question is solved. Now for the second question, I use case 2. Here again, the refractive index of another medium, which is filled that tends up to the same height, is 1.63. Now using refractive index is equal to real depth by apparent depth. Apparent depth. Refractive index is here given 1.63, and the real depth is what? 12.5. Apparent depth. Apparent depth. Apparent depth is equal to rest of the maths is simple mathematics. Okay. Apparent depth is equal to 12.5 by 1.63. By calculating this, I will have 1250 by 163. By dividing 1250 by 163, I will have 7.67. It means apparent depth will be of 7.67. Now the case is what? To what distance microscope should be shifted? Microscope should be shifted by calculation. I will have that by calculation normal shift. Now I am going to solve. Now the microscope should be should be shifted to is equal to apparent depth of the previous one is what? 9.4 minus the apparent depth of the later one is 7.67. That means second case. For the first case, apparent depth is 9.4. For the second case, apparent depth is 7.67. By calculation, now calculate, subtract 7.67 from 9.4. 9.40, 7.67, it is 3, 13.7, 1.73. 1.73 centimeter. It means the microscope should be shifted to a distance of 1.73 centimeter to obtain the image or focus on the needle again.